Hey everybody, welcome to the channel.
This video is about details on the SoarKraft airframe and whether one or two servos for control are the way to go by comparing benefits and difficulty. This is a quick build guide for either way, even if you're using the power pod. Whether you are building the pica, the stretch, or adding the V-tail to one of the other models, these all pretty much build the same way. Even if you're using the power pod, which will also fit any of the airframes, you eventually have to decide which is it going to be. One servo simplicity or two servo versatility. With one servo, it drives both surfaces at the same time. Straightforward elevator control, but requires a little twist, literally, because the control horns are not square with the hinge line. Many of my past models, like this carbon blade, got around this by using a double ball joint arrangement, which is also a little complicated. But I also had a nanofloa, and it used two brass flat control horns that are rigid front to back, but allow just a little bit of flex. Simple and easy for a single servo setup, which I thought would translate into printed horns well, and it did. PETG or PLA Plus are a good choice, but even regular PLA seemed to work fine, yet still removable and adjustable with the clevis. It's a little different than usual, and the main reason for this video. The control horn pushrod attachment for the two servo setup is perfectly in line with the hinge line, so no twist, which makes the two servo setup really easy to build. I could use these horns with the single servo, but would still require a forked pushrod, which ended up being more difficult than I wanted. So then, the two servo setup is easy to build. Each surface can move separately, so elevator and rudder functions are possible, and modern radios are easy to program for this, so it's available if you want it. But there are a couple of other reasons why I personally prefer a single servo setup to the two servo setup overall. First, because the wings are flat or have very little dihedral, the rudder function is rather limited. And I'm so used to flying aileron elevator controls, I never think to use the rudder function. But maybe I should practice? I definitely should fly more. I also chose to use a tail angle of 110 degrees, which, in airplane design theory, would be perfect. Or is it completely wrong? Lots of different opinions on this, and maybe something I should reconsider. But to what? Would reducing the angle a couple of degrees really boost the yaw effect enough to spend the time on it? Let me know in the comments below if comparing tail angles is worthwhile. I do, however, really like flaps and a 4-servo wing. Add elevator and motor control and you have 6 channels, which is a nice size receiver. To do the extra V-tail servo, you have to go to an 8-channel usually. Not a huge problem, but another detail. And then there is the removable tail, which probably could be done with a 2-servo setup too, with some marks and some patience. The single clevis is way easier. You don't need to check or adjust the trim every time you take it apart and put it back together because nothing really changes. And even changing sets completely only requires minimal trim adjustments if you build them the same way. Even switching out different fin material weights, as long as you adjust the overall CG, the elevator trim is really close. This makes switching out materials and colors fun and easy. One last note with using the power pod and the 2-servo tail. The servos are the smaller 5-gram servo size, not the 9-gram size. There just wasn't enough space to do 2 9-gram servos side by side. See my servo video if you want 5-gram servo suggestions. Alright, let's build this. This is the basic fin build after printing. All of this information is in the instructions also. Cut all the carbon to length. And test fit everything together. These 4-inch needle files work great for carbon channels. Once you're happy with the fit, let's take it apart and get it ready to glue. The front 2 carbon strips should stick out about 16 millimeters. And the control horn carbon should stick out about 5 millimeters. With the leading edge down, you can tack the carbon in place without it moving. Then stand it on in and add more. Repeat for the other side. Score the bottom of the hinge line with a file. Then flex it back and forth. File more if you need to. Do the other side. Make it move nicely, but don't break it off. Then with some silicone caulking and a paper towel, I coat the top and bottom of the hinge line. Wipe off the excess, a good thin coat on both sides. I use this method on just about every material hinge line, no matter what. Flexible, durable, and easy to repair, and has been tested to over 200 miles an hour. Clean paper towel to clean up any excess. Set aside to dry for an hour. Then flex it to check it out. Fix any problems. You can handle it now, but avoid the hinge area. Now is a good time to decide if you want to have a removable tail or just glue it on. To glue it, just flip it over and add glue to the 4 carbon channels, and glue it on before adding the push rods, just to be safe. Now, for a removable tail, we want the fins to be snug, but not floppy. This tail is particularly floppy, but we can adjust this. The foaming materials are usually a little tighter, and the older printers need the extra gap. The balance of making everything fit for all cases. So we need to add a shim. Great shim material for this is the purge line from the beginning of a print. I have these everywhere. This may need a couple of layers, so I'm going to fold it to double it up. Then cram it into the channel. You can cram it in the top or the bottom, but be consistent side to side so that the fin angle is the same with respect to the center line. You can trim it down if it's too wide. Once you get it in, you can use a piece of the 1x4 carbon to seat it in place and see if you need more. When you're happy with the fit, do the other side the same way. You can do all 4 channels if you'd like. A light drop of glue on each. Trim and let it set for a few. A quick test with the needle files. And a test with the loose carbon, and you're ready to check the fins. You can add more if they're not tight enough, and file more if they're too tight. Adjust until you're happy. Servo mounting is pretty standard. Location and size per your application. More information is in the instructions that come with these. For the 2 servo setup, I like to use the Dubro micro pushrod set. 2 complete assemblies with all the parts you need to finish. But I do prefer Z-bins rather than the plastic keepers. And there are larger sizes if you prefer. For the single servo, there hasn't been a perfect kit. I do like this Sullivan goldenrod, which is available again, which is kind of beefy and usually outlasts the rest of the plane. However, a little heavy for the lightweight builds. Also available again are bulk Sullivan clevises and couplers. I've also used this Dubro micro clevis for my lightweight builds. It comes with an 032 size solder-on threaded coupler, matched with an 032 size wire, and a 2mm by 1mm carbon tube for a sheath. Light, stiff, and a reasonable price. Size, cut, and solder to match your servo position. The clevis pin should be 16mm from the back bottom-most part of the fuselage tail. Of the 4 trimmed, ready-to-fly planes I checked, all measured the same. Huh, that's cool. With the servo centered, mark and make the Z-bend, and now we're ready for control horns. For the 2 servo with the Dubro kit, finishing the control horns is pretty easy. This is what it should look like when you get to the end. Alright, here's the order of operation. Cut the sheath. Add the easy connector to the horn. Slide the easy connector onto the pushrod. Glue the horn to the fin. Repeat for the other side. Set the servo centers. Tighten the easy connector screw. Cut off the excess pushrod and glue the sheath to the fuse ends. Now it's ready for programming and a test flight. Adding the horns for the single servo is a little harder. So I'm going to show how to do this step by step. The horns go on the clevis like this. I like to pre-bend the flat section. No sharp bends, just a gentle curve. Like this. I then glue on one side. This is where the removable tail is extra nice. Way more work room. Align it with the control surface. It doesn't have to be perfect though. The horn should be solidly attached before moving to the next step. Add the finished fin back to the fuse tail and attach both horns to the clevis. Add the other fin and slide the loose horn onto the carbon and push it all together. I sometimes add clips to the control surfaces to make sure that both sides are straight. Then, looking straight on from the back, I eyeball the surface position to each other. A tool can help force the horn around if needed for alignment. Then glue in place. Removing the horn is easy if you mess up and don't like the alignment. I use side cutters to cut the plastic off the carbon and then try again. After gluing the horns and letting them dry, remove the clips and finish the pushrod sheath attachment. For either servo arrangement, secure the pushrod sheath at both ends. There's a separate part for this on the slope nose and dedicated bosses for the power pod. The tail has an access hole for this. A drop of 5-minute epoxy works great and stays where you put it. It's done and ready for programming. Because of the large surfaces, you don't need much travel for elevator pitch control. And even with short servo arms, I rarely use over 80% max servo rotation. And then back it off even more with dual rates, set to 75% and 50%. And with the CG slightly nose heavy, the tail has a slight up trim. Highly recommended for stability and good behavior. The single servo and the 2 servo elevator function should work exactly the same way. Follow your radio setup for getting the 2 servos to move the same amount for balanced elevator control. Rudder function is capable of a lot of movement, but probably a good idea to dial it back for starting out. Then turn it up if you want. Well, that's how to build the SoarKraft V-tail. Which version do you prefer? Or build one of each. And if you crash it, you can always print another one. Thanks for watching. Please like and subscribe. And check out my other videos about printing, different materials and testing, and flying these SoarKraft designs to the limits of what's possible. This channel is funded by viewers like you purchasing my files on my website. for printing planes just like this, and helps me to continue to refine, develop, and share new ways of making them better, faster, and cheaper to hopefully benefit everyone. Or at least to have a good time. Nice. Thanks for watching and see you next time.